My name is Vishnu. I am a PhD candidate in the Computer Enabled Abilities Laboratory, or CEAL Lab, at Columbia University, and I will be presenting our work on ImageAssist and enhancing touchscreen-based image exploration systems for blind and low vision, or BLV users. So blind and low vision, or BLV users, often rely on alt text and captions to understand digital images, which play an important role in everyday life. However, prior work has shown that alt text can suffer from various issues. It can be error-prone, low quality, or maybe unable to do very detailed images justice. This leads us to a challenge. This challenge specifically being, how do we give BLV users richer views of images beyond alt text? And so many researchers have thought about this, and one method that's been explored is the use of touchscreens, such as those found on a smartphone, to allow blind and low vision users to survey regions of an image using their finger. Prior work has found a lot of benefits to these types of systems, including the fact that they offer a strong sense of agency and a strong understanding of the image to users. But exploring images via touch is a very involved process. And so these same works have identified a lot of cons. For example, the fact that users experience high mental load when using touchscreen-based systems for exploring images, and users can even miss information while exploring. Prior work hasn't really investigated these issues deeply, however, as to why they exist, and hasn't really proposed solutions. And so with this project, we set out to improve touchscreen-based image exploration. We first want to identify the specific issues present in these systems, and so we performed a formative study, where we had two blind users use a smartphone-based system we recreated from existing approaches to explore several images. Our formative study ended up yielding three major design goals to make touchscreen exploration much less frustrating. The first design goal involves providing a table of contents of the image so that users can decide for themselves what's interesting. Users had problems finding regions of interest to them or regions they hadn't yet swiped over at all. This was especially true for more complex images, which could have many details to explore, like the one shown on the screen here, which is a painting of the interior of a cafe. The second design goal involves giving users direction toward important parts of the image. Users try to explore the image by moving their finger around in a grid-like pattern. However, they couldn't really maintain this, and their finger pretty quickly ended up veering off course. A solution could be to help users better scan the image, but could we just get rid of the need to survey the image like this entirely, and nudge users directly toward the main characters or components of the image, so that they can survey those elements first? The third design goal involves helping users discover small and tightly clustered areas. Users found it difficult to discover small regions on the images and determine their relative positions, like for example the small bottles and glasses on one of the tables in the image. An ideal tool would make those small areas more accessible, especially on small screens. Now, given these three design goals, we need to understand how we can actually achieve them. And so we ended up developing and investigating a new system called ImageAssist, a set of tools designed to scaffold the touchscreen-based image exploration process so that users are strategically surveying the image how they want to survey it. ImageAssist consists of three tools that address the three design goals. We first set out to address the first design goal, which involves providing a table of contents. And so to do that, we created the menu and beacon tool. The menu part of the menu and beacon tool basically provides that table of contents. So in this particular image, which is a painting of a house in the countryside, the menu for this painting has 4 entries, one of which has already been marked as explored via touch, in this case the trees. We also have a beacon that directs users to a chosen area using a looping sound effect. So in this particular painting, the user is being directed toward the balcony. We then addressed design goal 2, giving users direction toward important parts of the image. And to this end, we created the hints tool, which consists of 3 components. The first component rests on the notion that the main characters or components of the image are often the most visually salient, and so the first hint we introduce, called the prominence indicator, we run the image through a neural network which calculates salience and changes the volume of spoken area names to communicate that salience output to the user. The second component involves communicating the logical main character of an image, which is reflected within an enhanced menu system. In this particular painting, the balcony of the house is logically the most important part of the image, given the two people sitting on it. However, in, for example, a floor plan image, a user might be better off starting their surveying at the entrance to the area in question, which might not necessarily be the most visually salient area, and then branching out from there. The third component, which is not shown here, is a simple first touch indicator that plays a small sound effect to alert the user when it's their first time touching an area of the image. The use of the indicator means that users can more quickly identify new areas while they're exploring. So that's the hints tool. Finally, we address design goal 3, helping users discover small and tightly clustered areas. We address this design goal by creating the quadrant zoom tool. The operation of the tool is simple. Users double tap any quadrant of the image to literally zoom into it, and then they can just survey that quadrant as normal. At this point, we've created 3 tools to scaffold the exploration process, but now we wanted to figure out how well these approaches work. And so to that end, we've performed a user study, where 9 BLV participants used the component tools of the ImageAssist suite alongside the status quo or baseline tool by itself to explore some images. Now let's look at a couple findings from this study. And we start off with the menu and beacon tool. Specifically, how did a table of contents affect participants' behavior in exploring the image? We found that participants saw the menu as supplementing touch exploration without necessarily replacing it. And this is supported by our data, where participants tended to touch more areas when using the menu and beacon, in this case a median of 100% of areas within an image, versus just 88% of areas when using just the baseline tool. Next, let's look at the hints tool. And in the case of the hints tool, participants felt that the prominence indicator, which communicated visual saliency, prompted them to think about the image differently. One participant talked about current representation, such as alt text and captions, being confining for BLV users. They went on to say that, quote, the prominence indicator gives you the insight to understand what other people might be seeing, while also telling you how things are laid out so that you can see things for yourself, end quote. This indicates that giving users the freedom to explore and not confining them to simplistic representations allows participants to appreciate the image even more. Another finding we saw with respect to the quadrant zoom tool in this case is that participants were split on their impressions of the quadrant zoom tool, and we can see this in this graph, which shows box plots of participants' impressions of each individual tool on a 20-point scale. We see that impression responses for the quadrant zoom tool span the entire range of possible responses, with the median being right in the middle. Sentiments were split in the sense that those with small phone screens found zooming incredibly helpful for surveying small areas, but some participants thought that quadrant zooming was difficult to use by itself, since some of them needed some direction or perhaps even a table of contents to deeply explore that quadrant. Now, our findings reveal several avenues for future work. One avenue involves exploring the aspects of an image that BLV users want to understand. We used prominence-based hints using the output of a neural network alongside logical prominence we determined manually, but participants suggested depth info and perspective info as other pieces of information, so future work can explore that. We also see several real-world applications for enhanced touchscreen-based image exploration systems. One such example may be in educational context, for example using ImageAssist to more closely survey a diagram, such as this one of the human brain. Another application may involve maps, looking more closely at maps before going into an environment. One could imagine using a more map-optimized version of ImageAssist that communicates distances and sizes to investigate this map of Penn Station. And a final application involves using ImageAssist to more closely survey images found on social media, including those that might have personal value to users, like, say, the group photo here. Ultimately, at the end of the day, our work with ImageAssist comes down to giving blind and low vision users a greater ability to explore images, especially those that they come across in their everyday lives and those that truly matter to them. Now, before I wrap up, I'd like to thank the entire project team for their great work on the project. If you'd like to learn more about the project, please feel free to visit our lab's website by scanning the QR code on the screen. And of course, thank you all for watching and listening.